Hi, this is Aly Hassan El Sokkary, 494260. This is an overview for the basic computer. I will pass briefly throughout the basic components that are used to build the basic computer. What's found here is the following. We have here memory, 6 registers, okay, and we have a control unit, and a ALU, and a clock, okay. Obviously, we have the 6 registers includes AR, which is directly connected to the memory, okay, and AC and DR, which are connected to the ALU, a TR, which is the temporary register, a PC, which is a program counter, and an IR register, which is an instruction register. The size of all of them are 16-bit except AR and PC, which denotes to the index of the memory, which have 6 bits. The question here, how are these components communicate together? Well, what I have done here is actually gathering all the needed assembly instructions. After that, I have written down all the timing of when each register should be enabled or cleared according to the timing signal from the control unit. Basically, I have read each assembly instruction and convert each instruction into the corresponding micro operation. According to that, I have derived all required expression to execute each instruction by deciding which loads, increments, clears, which will be set to 1, otherwise it will be set to 0.
Hello, this is Ziad Ahmed Mohamed, 4917833. I will discuss how the control unit is connected to the basic computer. Here, the IR is split into 3 parts. A part for the rightmost 12 bits, which represents the reference part. A part for the next 3 bits, which represents the opcode. And the most significant bit, which represents the mode either direct or indirect. Each part is decoded inside the control unit, and each output of the control unit is connected with the corresponding parts of the basic computer. Like here, we have, for example, the load of the DR is connected with the load of DR, and so forth. And in addition, we have the controls of the bus and the controls of the ALU. Here we have an equality checker between the AC and TR, which is always set to 0, because we have an instruction skip when accumulator equals 0, which have to check whether the AC is equal 0 before executing. So here the checker is ended with the output of the control unit and connected with the PC increment. For the
Hi, I'm Aly Ahmed. I implemented the inner design of the control unit. Here we have the sequence counter connected to a decoder in order to produce the timing signals, as here is T0, T1, T2, and so on. Here is another decoder connected to the opcode bits of the IR register in order to decode the instructions. The 12 rightmost bits of the IR register were used to decode the register reference instructions. The decoded instructions and the timing signals were both combined together through logic gates based on the expressions derived by my colleagues in order to produce the control signals for the loads, increments, and the clears of the registers, bus controls, and the ALU controls. This flip-flop here was added in order to delay the clearance of the sequence counter.
As we can see here, the program instructions is added to the memory. Origin is 0, so the program will be executed from index 0. The first thing that will be done is to load the value at the index A to the AC. The value at the index A is 2. And now the value at the AC became 2. And then we will add to the AC the value at the index B, which is 5. So the AC is expected to be 7. And it became 7. Then we will subtract the value at the index C from the value at the AC. The value at the index C is 7. So the AC is expected to become 0. And it became 0. Then we will skip if the AC is 0. And actually the AC is 0, so we will skip the next instruction, which is branch to N1. And we will go to load B into AC. The value at B is 5, so AC will become 5. and it became 5. And then we'll branch to the instruction at the index N2, and it is AND A. So we'll AND the value at the index A to the AC, and the value at the index A is 2. We will AND it to the AC, which is 5. And as you can see, the result of their ANDing is 0. Then we will store this value to the memory reference D. And as you can see, it's stored in D, which is 0.